We've got some level design here, and we've got lighting, and we've got post-processing, but still we're using this checkerboard pattern. So today, let's take a look at the basics of materials in Unreal Engine. One of the big upsides of using Unreal Engine is that you can actually use a lot of high quality pre-made materials. So if we come up here into Window, we can open Quixel Bridge, which is a kind of gigantic library full of 3D assets, so models as well, but also a lot of materials that we can use. So you can see here, there's models, there's plants, and there's a bunch of materials. Today we're going to be looking into the materials. So if we look into surfaces here, we can see a bunch of different categories as to what kind of surface we want. Let's go for a stone surface here today. And here I chose a castle stone. So we can say we want the castle wall. And then we can choose whether or not we want low, high, highest, or medium quality. Usually medium quality is good enough. You should be aware of using high quality and highest quality assets really starts eating up a lot of video memory, which is usually a big bottlenecking point for your graphics. And once you're signed in, which you can do with your Epic Games account or whatever other type of account you want, you can download this asset, for instance. And let's also, because this is a wall, we can't use a wall on everything, so let's also use this castle cobblestone, and that we will use for the flooring. It also gives you a bunch of related assets and even the collection that this comes in. So if you want to make a castle ruin, there's an entire collection for that which we can download and have a bunch of assets to work with. Especially for things like prototyping or a game jam game, things like that. This is fantastic. Once you have those downloaded, it will show up here in your local folder under Mega Scans. And you can see I already have a bunch of assets here from previous projects and videos, which I have stored locally. And once the two materials that I'm downloading are done downloading, they will show up here as well. And I'll be back with you in a second. So the castle cobblestone is finished downloading now. And once we have that, we can select it through our local folder here. And then we can add it to our project, where it'll just make a new folder, Megascans, surfaces, and then one specifically for this material. And that will create a material asset that we can use in a moment. And now it's as simple as just drag and dropping your material onto whatever surface you need that material on. And you'll see that with these box brushes that we've been using, we can actually do this on a per face basis. If you do this on a full static mesh, which sometimes with entire actors, it's a little iffy on that. So we can go into the cube static mesh components here. If we go into all, we can then see the material that this is using. We can always just drag and drop that into there as well. If we just lower this a little bit, we can drag and drop it into there. And you'll see it actually does the entire model. So the way we can do it on a per face basis is very much just something we can do for these box brushes, which is part of what makes them so fantastic. So if we select our faces here on our box brush and come into the details panel under the brush component, we can see surface options here. And there we have the UV scale. And long story short, this is just the scale of the texture on your object. So we can see that if we change this to 2 and we turn on this lock so that it's always proportional, when we apply, the texture becomes bigger. If we want it to be smaller, we can set it to something like 0.5 instead, and now the tiling becomes smaller instead. I think something like 2.25 probably would be pretty good for what we're going for here. And we can do the same about all that on all these faces. So here again, we can also go into our UV scale, let's say 2.5 for both of those as well. Do make sure that these are the same number. And then we can use this cobblestone wall for all these other faces around here as well. And then naturally, the tiling here is way too small as well. So let's actually set this up to a bigger number, something like 3 right away, because that's going to be pretty necessary. Well, it ain't perfect, but it is already looking a hell of a lot better. And to be fair, this box brush method that we've been using, usually you would only use this to block out your levels. You wouldn't often really start to apply the actual materials to this. Usually you want to replace this with your own static meshes that you have made in Blender or Maya or whatever. So for now, this is still looking pretty flat and not finished, and that is because it is. Anyway, there's a really good way to quickly put some graphics on your levels, but you're going to want to do something more than that, right? You're going to want to make your own, and that can be very complex in a lot of ways. So we're going to go over the most important things to understand and how to set up your own materials. So going back into our content folder here real quick, we can just simply right click and make a new material, and we'll call this something like test material, which is a very bad naming convention. You probably should prefix this with something like mat and then the name of the material itself. That gets us this interface, and there's a lot of things to talk about here. So we've got our details panel here where we can choose a material domain, a surface, a decal, a light function, a volume, post-process, or a user interface. We're going to stick with surface materials for now, so don't worry about the domain. The blend mode is a little bit more important. Most of your materials, where possible, are going to be opaque, meaning that you're not going to be able to see through them at all. This is the cheapest for rendering. We also have masked and translucent, and the other ones I'm going to skip over for now. These are the three you're going to be using the most. So what's the difference here? Opaque, you can't have holes in your material at all. So anywhere where there is geometry on your 3D model, there's going to have to be something to see. Whereas if you go into translucent, you will note that there is a fair few things that go blank here, like the metallic, the specular, the roughness, all that kind of stuff. But instead, we do get an opacity. And I'm just going to add a quick value here. And we can see that if we set the opacity to 0, this thing disappears. But if we set the opacity to 0.5, we get a see-through material. Now, that's really cool because we can now make materials that are see-through. So things like glass are now suddenly possible. And oftentimes you'll want a water shader to also be somewhat see-through, that kind of thing. That's where translucent materials really come in handy. They are pretty expensive to compute for your GPU though, comparatively speaking. So only use translucency where needed. And that is where masked materials come in. You'll see that the opacity is no longer available when we go to masked, but instead we get the opacity mask. And this is not a you can see through it kind of deal. What you can do with an opacity mask is just say these parts of the image you can see, and these parts of the image you cannot see. So if I plug the 0.5 into here, that'll do nothing, because it won't disappear unless it's actually set to 0, at which point you will note that it has some trouble with like the shadows and stuff like that. We're not going to worry about that too much right now, but this is a cheaper way of creating holes and see-throughness in your materials. So let's just real quick, I'm going to add a noise into here, into the opacity mask, and you will see that we now have holes poking through here. And if we, don't worry if you don't understand what's going on here, but if we add some texture coordinates and we do some other good stuff here to make this all work, we can now make this noise pattern a little bit more manageable for us. So let's say we want to have this at scale 50. Is that a little too much? That actually kind of works. So now we have this material where we have a noise pattern where some parts of the noise make the material visible and other parts make it see-through. Again, don't worry about the whole texture coordinates and noise node and the multiplication and this appending and all that kind of stuff. We're going to get into that at some other point. Matter of fact, the whole material stuff is complicated enough to the point where it could have a series in and of itself, which I probably will do, because otherwise this would go on for way too long in a course that is supposed to just cover the basics. So let's go back over all these different inputs, at least the inputs that are the most important. And we're going to go back to a opaque material, because most of your materials are going to be that opaque. We're going to talk about the base color, the metallicness, the specularity, the roughness, the emissive color, and the normals here. Everything else is a much more niche use case, which we're not going to get into right now. So the base color is exactly what it sounds like. It's a color. So if I hold the 3 key on my keyboard and I click anywhere, that gets me a vector 3 value, which is literally just a color, right? So I can just say the color here should be this pink. And if I plug that into the base color, we'll now see that our material is a pink color. And I think what we should do, because we have these coins in our game, which don't really have too much going for them as far as material go right now, I think what we should do is we should make a material for that coin. So let's make it gold, which we can do by making this thing a yellow color. But this still doesn't look very gold, does it? And that is where our second value here comes in, the metallic value. This is literally a value that just makes things look metallic. Don't ask me what it actually does mathematically speaking, because I don't know. Just when this is 0, it's non-metallic. When this is 1, it's very metallic. You can give it a value in between 0 and 1 if you really want to. Generally speaking, metallic is a value that you just put at 0 or 1. So if we put 0 in here, you'll see that doesn't change anything, because I believe by default the value for this is 0. And then when we set this to 1, we can see this now looks a lot more metallic. It does something with the reflectivity, but in a different way from actual reflectivity, because we're going to get to that in a moment. Oh, by the way you make this little node over here is just holding a 1 and clicking. That's how you can make a scalar node. And in much the same way, we're not going to get use out of that today, but you can also hold down 2 and click, and that gets you a node with just 2 values. Which you might be able to see if you use the top pin out of these nodes, the white one, you get both of the values. So you get a vector 2 or a vector 3 value, much in the same way that we have the positional data in our blueprints. That's a vector 3. It has an X, a Y, and a Z value within one variable. But you can also just use the X value or the Y value, and in the case of the vector 3, the Z value separately. So if we just put in this red pin, you might think, oh, it's going to be red. No, it's not going to be red. It's just going to give you the X value from this vector 3. So we can see that's pretty high up, because apparently yellow is pretty close to red, which makes sense because yellow is red and green combined. So if we put in green, we also see that's pretty good. But if we put in blue, we can see that'll be a lot more dark. And it's important to note here, because we're separating these things out, they lose their color value, because colors always are a red, a blue, and a green combined together. So these will output grayscale. Anyway, we have a little bit of a golden color here, but we probably want for a coin, we want it to be nice and shiny, look like a freshly minted coin, right? And that is where the roughness comes in. We'll get back to specularity in a moment, because that's a lot more technical and generally not something you really want to mess with. And the roughness, again, is just a single value between 0 and 1. And by default, that is set to 0.5, so halfway through. If we plug in 0, we'll see that the roughness makes this thing pretty much look like a mirror, meaning that it's going to be very, very reflective. If we set this all the way up to 1, this thing becomes very non-reflective, at which point that generally doesn't go that well with metallicness. But if you don't have a metallic material, it kind of feels kind of chalky, almost as if it is, well, made of chalk, because chalk disperses light very evenly. It's a very matte kind of material. For this coin, I think we're going to want something like, let's do 0.25. That seems pretty good for this material. Now, we're going to take metallicness out of this for a second, because I need to explain specularity to you. Do you see this? I think you can see my cursor. Yes, you can. Do you see this little bright spot up here? That is a specular highlight. And in very technical terms, a specular highlight happens when the reflection of a material reflects directly into your point of view. So we have a light source somewhere around here hitting this spot, and a lot of the reflective light just goes all over the place, and we just get the general color. But the rays of light that directly bounce from this surface into our camera, they become these highlighted white spots. And if we set the specularity to 0, you'll see we don't get any of those spots. So the specularity is more or less just a value as to how sensitive your camera will be to that reflectivity. It's not quite how it works, but that's the easiest way to think about it. So if we set this to 1, we'll see that it's a lot more aggressive. And of course we can go somewhere in between, so 0.5. We'll see it's a little bit less aggressive. It's not something that you usually mess with a lot. And now if we combine that with metallicness, we can once again see if we go 1 and if we go 0, the metallicness kind of does something with the specularity as well. So that is, again, generally something that I don't mess with, but something that is important to know about. The next one that is going to be very useful for you to know about is the emissive color. For our golden material, that's not really going to be too relevant, but let's, instead of using the base color here, let's use the emissive color instead. And that gets you a very similar result, other than the fact that suddenly things don't look metallic anymore. And that is because this thing no longer is really receiving light. It's emitting light. So, whereas before, what we saw was the light of the world interacting with just the surface color of this material, now this material is actively generating its own surface color. And if you have lumen global illumination enabled, this will also actually emit light into the world. And the really cool thing about emissive colors, and this is very easy to fall down into a rabbit hole of using this to just make things look good, and to a certain extent that does work. But if you multiply this color value before putting it into the emissive color, if this color value goes beyond a value of 1, which you can't do in just picking a color, sadly, but if we just multiply this by something like 10, you will see that it starts to approach looking white, but it's actually glowing around the edges of the, well, in this case, the sphere, whatever model it's on. And this glowing, this blooming, is something that for emissive lighting, the engine has built in. And if we take this to its extreme and we do 100, you'll be able to see at this point, it's more or less starting to look like a sun. Then again, we're trying to make a gold coin here, so the emissive color isn't really gonna be that important. But in the next video, we're going to be talking about particles. And if you're making specific materials for particles, more often than not, you're going to use emissive outputs for particle materials. Not always, but generally speaking, that is something that I do, at least. And just for the comparison, if we just put this into the base color, it's just gonna end up being white, because the base color is just kept at pure white. It can't display anything more than just pure white. Then the last important pin here, there's a couple more pins that we could talk about, but the last very important pin here is the normal pin. And this requires a little bit of explanation as to what normals are in the first place. Because if you're new to 3D, you probably don't know what a normal is. And you're like, oh, that's just what it normally should look like. And that's not what that is. A normal is a direction. So let's save this material real quick and go back into this map just so that I can show you through this cube. So we've got this cube here, which has a number of sides. And each of these sides is one polygon. Those polygons all have a direction they are facing. And if you don't do anything weird with your normals, by default, that is perpendicular to the surface of that polygon. So for this top polygon here, its normal is just pointing straight up into the sky. For this polygon over here, its normal is pointing over in that direction. For this one, its normal is pointing over into this direction, perpendicular to its surface. Which is very important when calculating light, because the normal is what decides how a face, a polygon, should be lit. If for some reason your normal is facing the wrong way around, that face will get lit as if it is turned around. So if we turn the normal for this top polygon, instead of going up to be going down, if we put a light above this face wouldn't get lit. Instead, it would get lit if we put a light below it. And you might be thinking, okay, so why is this relevant information? That's how the lighting of the engine works. That is way too deep for me to even care about understanding how and why that works. But here's the kicker, right? That is done on a geometry level. So if you want to add more detail for light to be able to interact with, you need to add more polygons, which is generally a pretty expensive thing to do as far as your computer goes. Adding more lighting information onto a lower poly model is something that does persist. And that is where normal maps come in. A normal map is a texture, just like any normal texture that you can use, which has information about these normals, so the face direction, on a per pixel basis instead of a per polygon basis, making it much more cheap to store and making it much more cheap to calculate, because you don't actually have to render all those polygons facing in different directions. The engine just needs to know, okay, a light ray hit this pixel and this pixel is aimed in whatever direction. So if you have a normal map, you can put it into this little input over here. And I'll show you one of the materials that we downloaded before. You can see this is a different interface. We'll get to that in one moment. But you can see that it has the just regular texture here. It has a place for metalness, ARD, we're not going to talk about that at the moment. And then it has a normal texture. So if we open that up, we can see that we get this really weird blue image. And this is what a normal map looks like. So every single pixel here has information on the red, green, and blue channels, which corresponds to the X, Y, and Z directions in the world. So if we zoom in a little bit, we can see that these pixels over here are a lot more red. So they will be rendering the light hitting it as if these pixels are facing into the positive X direction. Whereas these pixels over here are a lot more green. So they will be rendering as if they are facing in the positive Y direction. Usually the base color of your normal map is this kind of lightish purplish color, which you can just think of as a neutral normal. That is a lot of information and a lot of technical mumbo jumbo. So let's try to make a procedural normal map here for a sec. So if we do all of this stuff here to make our noise into a normal map, we can see that there's all this detail here, which looks like there's just a lot of geometry. But if we zoom right up close into it, we'll be able to see that, in fact, the geometry here still is literally just the same sphere that we had before. And all of the extra added detail that we can see here is actually simply different light interactions with the surface. So if we go into our coin here and put that material on that coin, we'll be able to see that we probably need to change a fair few things about the scale here. But we have all of this detail, which is purely coming from the texture and will interact with the light. So if we put this closer to a light, where's the nearest light? There it is. If we put it closer to a light, we'll see that it interacts with that in interesting ways. That said, we're making a coin here, and I don't think particularly that we need to add normals to this coin. And if we did, it would probably be in the form of a normal map and not something procedural, which gets me to one very important thing, and that is the way you're going to set up most of your materials, or at least a lot of your materials, is by using texture samples. So this allows me to put in a texture, and by default the engine comes with a few textures. So let's use the brick normal map here. We can use that to put that into the normal map here, and now we have a golden wall. Very simply by just adding a normal map. This is how much detail you can get out of normals. And if we copy over that texture sample, and instead of the normals, we'll use the base color here. And just like that, if we disable the metallicness here, we have a wall. So very often you'll export your materials, your textures, which includes a base color map and a metallic map and a specular map and a roughness map and normal map and maybe an emissive map and whatever as textures. out of either Blender or maybe something like Substance Painter. If you use that, you'll get these images and those will just simply put into your material like this. And then there's a bunch of different things that you can do to influence those image textures. And of course, there's a lot of things that you can also do to make materials entirely in engine procedurally, like using a lot of noise textures and stuff like that. But for now, we simply want a shiny gold coin. So we're going to remove all of this and stick with just our gold coin, which looks pretty good at this point. One last thing that I want to show you though, now that you understand the very basics, is material instances. Because right now we just put the material that we just made onto this gold coin. But what if we want a different color as well for metal? Maybe you want to have a steel coin as well. Well, what we could do is, of course, we could make a whole new material and replicate this setup and just change up the color here to be less saturated and a little more gray, and we have something steel, which is fantastic, except for the fact that if you have a more complicated material, that's going to get very tedious if you want to change something after the fact. As well as having a lot of different materials is also something that is pretty expensive to render. So you want to limit the amount of materials that you have. And the way you can do that is by making material instances. So if we go into our content browser here, we have this as a material, and I'm going to call this a shader or a master material. And those are the ones you want to limit your use of. So you want to have as few shaders or master materials as you possibly can. The amount of material instances, on the other hand, is not that relevant comparatively. So you right click on that, you can create a material instance, and let's call this material gold, and let's create another material instance and call this material steel. And these will just function as any other material. You can just put them into where you want to have them. And let's make this block over here, for instance, have the steel material, which you can also, if you have an asset selected here, by the way, you can use this little arrow icon to put the selected assets into here. So this doesn't look like steel though, because we haven't set up the color yet. And the way we do that is going back into our master material, our shader. We can right click any of these little value nodes here. In this case, we're going to right click the color, and we can convert this to a parameter. So we'll call that color. And now if we open up our material instances, we can see that it has these parameters here. So we can enable the parameter for our color, and now we can change this color around to whatever we might want it to be. So if we open up our steel, we can change this to a more gray color. And now we're using the same material in two different instances with one parameter difference. And we'll see that now this thing looks a lot more like steel, while this one still looks like gold. And if you have been paying attention, you will have noticed that the Quixel Megascan materials are also material instances. So if we open that up, we see this interface, which we've seen before, because these are all material instances and these are all parameters that are made available through its parent material. And if we open that up, we get this, which is a whole complicated mess of different things, which we're not going to get into right now. These materials are very complex setups. And with that, I'm going to end off this video about materials. So we've learned a lot today. We've learned about Quixel, which is a very useful and nice tool to have in general for materials, but also for assets. We've learned about all of the technical stuff around materials and how to make material instances. So there's going to be quite a lot of information in here. Do feel free to watch this back 2 or 3 times in the future as you go along and learn more and more. I don't expect you to have all this information stick right away. As long as you have a general idea of how things work, that will be plenty enough to move on to particles next time. And the reason that you need a general idea of how things work is that while particles are a thing in and of themselves, a lot of the actual cool stuff that you're doing with your particles will also come back to the material that you're using for those particles. So we'll look into that next time. And for now, thanks for sticking with this very long explanation. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thank you to Eleanor for supporting at the Cave Digger tier on Patreon.